sides of the equation. Let's set up an equation. Let's say we have x divided by 3 equals 4 divided by 6. Now this is a really easy equation to solve, but some people get rightfully confused with this. So the first step you need to think of is, how do you get x on its own? Well, you have a look at what is joined to x. X wants to be a loner. He wants to be on its own, and at the moment he's got a number 3 joined with him. So to get rid of the 3, which is on the denominator of both of this side, we need to multiply both sides of the equation by 3. So we're going to times this side by 3, and we're going to times this side by 3. A quick trick of doing this is just moving the denominator from one side of the equation, and then when it goes to the other side, it becomes a numerator. So this is the step you need to remember. This is times by 3. So now this is no longer a fraction, or a fraction that's necessary to write down, and x is equal to 4 divided by 6 times by 3. It doesn't matter whether you do 4 times 3 then divide by 6, or 4 divided by 6 times by 3, or you could do 3 divided by 6 times 4. We can move these things around as long as these two are on the top and this is on the bottom. It doesn't matter which way you have them round. For example, you could have 3 times 4 divided by 6, because we know that 4 times 3 is the same as 3 times 4. Pause the video and copy this down. Hopefully you managed to get to the answer of 2, because 12, which is the numerator, divided by 6 is 2. Now let's have a look at a more complex example. Let's say that this time we're going to have the x as the denominator and the number as the numerator. Now the problem is, x wants to be alone. He wants to be a loner. However, at the moment he is the denominator, and this is not the place to be. X wants to be high in the sky looking at all the views. He doesn't want to be down below this line. So, like before, we're going to times both sides by x, and this quick trick with fractions means the x moves from the denominator of this side to the numerator of this side. Excellent. We can now get rid of this as a fraction. Now, if we wanted to find out what x is, we need to move the 6 and the 4. We can move them together or separately, but I'm going to move them separately so you understand. The first thing we're going to do is we're going to times both sides by 6. This means the denominator goes from being a denominator on this side, and on this side it becomes a numerator. However, it is not 36. This is wrong. When the 6 is moved up, this becomes a times by 6. So make sure you are aware that 6 being moved, or if you times both sides by 6, which effectively moves the 6 from the denominator to the numerator of the other side, that it becomes times by 6. This technically should be a curly x, because I think what we're doing is probably getting confused with the times and the x. Or we could use it as a symbol, for example. So we could replace this with an apple. So this time, rather than finding x, we could be saying what is the value of the apple. Now, in order to get rid of the 4, this time, like before, we're going to move it from the numerator and we're going to move it to the denominator, because we're going to divide both sides by 4. So our value of our unknown, or our value of our apple, as we've changed the variable to be apple, is going to be 3 times 6 divided by 4. That's going to be clearly 4.5. Now let's go over a final example, and this time I'm going to add in some sine and cos values, or one or the other. Let's say this is sine x. And let's say this is sine 30. Or perhaps I could name this something a little bit more straightforward, such as sine 90. Now, there's a really quick, cool thing you can do. If you don't like having the x on the denominator and you don't want to move everything around, effectively what you can do is just flip them upside down. Not quite like this, but I'll show you exactly what I mean. So this is another option to rearranging it and making it complex. You can put all the denominators on the numerator or the numerators on the denominator. Really cool trick. Let's do that again. Now, we want to find out what x is. And now we know that this equation at the top is the same as the bottom equation. We can forget about the equation above and we can just focus on the equation below. Again, x wants to be a loner. We want to find out what x is. So we need to remove anything which is associated with x. The first thing, because sine and x are together at the moment, the only thing you can remove from x is the 3. Now the opposite of divide by 3 is times by 3. So we're going to times both sides by 3. And what happens is the 3 jumps up here. Now what a common thing people get confused with is they don't necessarily know the difference between 3 times sine 90 over 4 and another option could be 3 times sine 90 over 4. Now they look different, but actually they are the same, and this is because it doesn't matter what order we do these operations in. As long as these two are times and then it's divided by 4, it doesn't matter whether you do sine 90 times 3 or 3 times sine 90 before you divide by the 4. Final step is to make sure we calculate what x is. So to do this, what we would do is we would find the inverse of sine. Now the inverse of sine on a Spanish calculator is arcsine, or on English calculators it's sine to the power of -1. So the sine goes to the other side, but this time it's transformed to arcsine. Now everything else is the same. All we've done is we've moved the sine. Let's highlight that in a relevant colour, preferably not yellow. The sine has been moved from the left-hand side to the right-hand side, so we found the inverse of sine, which is arcsine, and we still want to find what this fraction is. We still want to find arcsine of this. What you would do is you type that into your calculator. Now, if you've got a calculator to hand, that would be a brilliant next step. And we are going to get the following. Arcsine, or sine to the power of -1, I'm going to type in 3 times sine 90, all divided by 4. Now, this isn't a particularly normal question because it's not to do with triangles, for example, because you wouldn't be calculating necessarily the sine of 90. Now, what I've got for my answer is 8,717. Please let me know in the comments if you agree or disagree with this answer, and thank you very much for watching.